Okay, trigonometry. Today we're going to talk about special right triangles. And you don't have notes like this, but this is a review from your geometry days. So hopefully it'll come clear to you. If you remember, there's a couple special right triangles. Right means that you have a right angle. And the ones we call special right triangles are those, first of all, 45 degrees and 45 degrees. So 45, 45, 90. And the special relationship between this, first of all, is that it's isosceles, right? So that two sides are the same. So namely, if this side is x, then the bottom side would also be x. It should make sense that those are the same. And if you do the Pythagorean theorem to come up with c, x squared plus x squared is equal to c squared. We get 2x squared is equal to c squared. And if you square root both sides, you get square root of 2x squared is equal to c. Or if you take out the x, you end up with x roots of 2 is equal to c. So therefore, we always know that any side of a 45, 45, 90, the two legs are the same, but then the hypotenuse is equal to whatever this side is, x, and you multiply it by the root of 2. So I'll do an example in green. Suppose that x was 4, then the other side would also be 4, and the hypotenuse would be 4 roots of 2. Okay? Pretty simple. We also have a 30, 60, 90 triangle. So this more angle 30, 60 degrees. What's interesting here is a 30, 60, 90 is exactly half of a 60, 60, 60 triangle. So half of an equilateral. So if we call this hypotenuse side x, then the shortest side is exactly half of that. X divided by 2. Now, you probably didn't learn it like that as x over 2 and x. Probably how you learned it was if this is x, then the hypotenuse would be double, so 2x. Okay? So the hypotenuse is always double the shorter side. If you would use the Pythagorean theorem and solve for the other side, we take the shorter side x, and this time we multiply it by the root of 3. Some of you remember that. So I'll do an example in green real quick. If x was 5, then the hypotenuse would be 10, and the longer leg would be 5 roots of 3. Very simple. We'll do a couple problems on your sheet together. Make sure your name is at the top. So they want you to find W and Y. You can see this is a 45, 45, 90. Relationship W would be 4, and Y would be 4 roots of 2. The next one, the shorter side is 2, so therefore Y would be 4 because it's double, and W would be 2 times the root of 3. You could continue to do that work all the way around, but if you flip to the very back side, let's just look at a problem that might be a little bit more difficult. Okay? So if we look at 18, we want to solve for y and for w. And if I look at my information, I have 30 degrees, I have 90 degrees, so therefore this angle must be 60 degrees. So therefore the triangle in red is a 30, 60, 90. W is across from 30 degrees, so it is the shorter side. So this could be half the hypotenuse. So W is equal to half the hypotenuse, which is 4. Got a 4 right there. If you look at the blue triangle, it is 60 degrees, has a 90-degree angle as well, and then 30 degrees over here. You can see that W is equal to 4. That means that the longer leg of the 30, 60, 90 is equal to 4. Well, normally you would take y and multiply it by the square root of 3 to get 4. So what we're going to do is to get y, we take 4 and divide it by the root of 3. If you want to find the smaller side, instead of multiplying by the root of 3, you divide by the root of 3. You have to simplify that by multiplying top and bottom by the root of 3. And you get 4 roots of 3 over 3. So y is 4 roots of 3 over 3. Yeah, that's that relationship. So anyway, I know that a couple of these problems will be challenging for some of you guys. You simply want to find the missing sides. Go ahead and work together, but this is excellent review because in order to work with the unit circle, when I get back on Tuesday, you're going to have to be able to do 30, 60, 90 triangles. So enjoy some geometry review. Hope it goes well.